Alright, we're going to pick up where we left from last video. We talked about uh, the climatic types on land, and we covered deserts and monsoons, and we talked about plateau, and I've mentioned that we're going to focus on two plateaus. The first one we already covered is Tibetan Plateau, and then now the second is Tibet. We left it here. So then the second one is the Altiplano. The high plateau of the Altiplano, so around 18 degrees south, is an average latitude of 3,050 meters and covers about 100,000 square kilometers, with the Andes Mountains to the west and dissected mountains to the east and north. It has a dry, steppe climate, an analogous to Tibet. An upper-level anticyclone, the Bolivia High, forms over the Altiplano in Austria summer, January. Rainfall over the Altiplano is less than 700 mm and declines from north to south. It is mainly concentrated in the austral summer month, especially in its southwest part, where over 70% of the precipitation occurs in December to February, according to Garriott et al. It arises from deep moist convection, where the moisture is transported westward from Arizona. Located to the east of the Altiplano, the rainfall occurs in wet episodes lasting about a week, separated by dry spells of similar length. Southward displacement of the Bolivian high gives rise to stronger easterly flow aloft. However, much of the moisture is derived from regional slope circulations along the eastern Andes that draw in moisture from the boundary layer over the adjacent lowlands. Interannual variability of rainfall in the region is linked to ENSO, with La Nina phases January being wet. However, the 1988 to 1989 dry La Nina and the 1972 to 1973 wet El Nino seasons in the Altiplano were exceptions. In these years, the spatial pattern of zonal wind anomalies led to these different responses. In May to October, mean westerly flow dominates the Altiplano region, resulting in dry conditions. The highest mean temperatures of negative to 20 degrees Celsius is in spring. November, in a value of 13 degrees in winter. Minimum temperature are around 1 to 5 degrees Celsius in summer and -11 degrees Celsius in winter, with a winter diurnal range of 25 to 40 degrees Celsius as a result of the pronounced radiational heating and cooling. Okay, the high plateau we just talked about, and now we're going to look that a very unique feature here. So the prominent feature of the antiplano is Lake Titicaca with a surface area of 58,000 square kilometers. The surface, the influence of such an impressive body of water is felt by a reduction in diurnal temperature range, and the net effect is to increase the mean annual temperatures by 1 to 2 degrees Celsius within a few tens of kilometers of the lake margin above those in the surrounding region. This sets up a local climatic belt around the lake. The lake, with water warmer than the surrounding air once the sun sets, also influences precipitation, which is greatest at the lake's center. Annual precipitation totals over the lake are increased by about 15% above those in the surrounding area. Mean annual precipitation over the lake is 880 millimeter versus an annual of 766 millimeter in the surroundings. Lake Titicaca, because of its area and volume and its situation at high altitude with the tropics remains a hypotropical site unique in the world. So now we can see Lhasa and Julica, the annual temperature and rainfall by hypergraph for Lhasa Tibet and Peru, Julica. So it's in blue color. Okay, then we move to another one is weather climatic type is wet lowlands. It's a very important one. So wet lowlands, the major wet lowlands of the world, AF climates according to Köppen, are in the great equatorial river basins of the Amazon in South America and the Congo, Africa. The Amazon River basin covers about 7 million square kilometers. Its thermal regime is distinguished by its constancy. So temperatures vary diurnally but show almost no seasonal change. Mean monthly temperatures at Manas range between 26 and 29 degrees Celsius, but the daily range is about 8 degrees Celsius. Wow, that's very nice. Annual precipitation at Manas is 22 and 80 millimeter with a maximum January, April, and a minimum July to September. Over the basin, annual totals range from 3,500 millimeter in the west between 4 degrees north and 4 degrees south to 1,500 millimeter in the east. Typical rainfall amounts of 2,500 millimeters are associated with evapotranspiration amounts of 1,200 to 1,500 millimeter annually. About 75% of the moisture for precipitation is advected from the ocean, while at least 25% is recycled evaporation from the land. Deforestation is having important impacts on the hydrological cycle. Removal of forest leads to a reduction of surface roughness and an increase in albedo that lower evapotranspiration and therefore precipitation, while the albedo increase also results in less moisture flux convergence in the atmosphere surface reducing precipitation. The diurnal characteristics of tropical rainfall are summarized here. In the dry season, there are easterlies from the tropical Atlantic that have a shallow, relative cool, humid layer overlain by drier, warmer air. In central and southern Amazonia, there is a continental heat low from October to April with substantial precipitation. In November, cold fronts may affect the southern margins of the basin. In northern Amazonia, the raining season is from May to September, associated with low-level convergence in the equatorial low pressure, rough and instability lines. The ITCZ is only evident along the coast where it migrates southward about 5 degrees south from December to April and then northward to 10 degrees north in September to October. In the east, a significant source of rainfall is instably line formed by coastal convergence in the trade winds, or convergence between nocturnal land breezes and the trade winds. Most of these instability lines die out as they travel about 100 kilometers inland, but some persist for 500 kilometers and a few may reach the eastern Andes. Extra extratropical disturbances that cross the Andes from the South Pacific affect the mid-latitudes and subtropics between 20 degrees south and the equator. There are about 2 such systems per month throughout the year. These contributes to the rainfall in southern, southwestern, and west central Brazil, according to Satamati et al. In the austral winter, cold air surges called fragimes. The air moves. Fragimes. The air moves northward into Amazon basin from the south affect northern Brazil. Then a Pacific low pressure system enters a Chile and Argentina. Low temperatures in June and July are a major hazard for Brazil's coffee production and so raise coffee prices. So the diurnal character of tropical rainfall, the classical picture of tropical rainfall is that it has a distinct diurnal cycle. Cumulus cloud builds up as the surface is heated during the day, leading to the formation of cumulonimbus in the afternoon and downpours of rain and thunderstorms. Rainfall rates diminish in the evening hours, reaching a minimum in the early morning hours, where mesoscale convective systems are important. However, land areas have a peak rainfall for late evening to midnight as a result of their longer life cycle compared with individual thunderstorms. Over tropical oceans, there is only a weak diurnal signature. There tends to be an early morning peak, which is associated with the occurrence of mesoscale convective systems.